So this lesson is on the application of quadratic equations. Okay, so one of the types of questions you're going to see on your final exam are some that ask you about perimeter or area of a rectangle. So we're going to do a couple of problems like that. It says, given the diagram below, find the value of x if the area is 21 square meters. So we have this rectangle, and area is length times width. And that's what it's saying area is, and it says area is 21. So we want to solve this. So we're going to multiply this out, and then we're going to move our 21 to this side, subtracting it. Okay, so we're going to get a polynomial like this. So we've factored these. We're going to factor, split the first term. Our signs are different. And when we multiply to get 21 and subtract to get 4, we can use 3 and 7. Now I need a negative 4, so that means the biggest number is going to have to be negative. Okay? Now, we now need to solve. So that means we take each of these factors, put them equal to 0, and we solve them. So negative 3 is going to be subtracted to move it. So it's negative 3. 7 is going to be added to move it. And that is 7. Now, our positive value for x is what we're going to use. So if x is 7, then our width is 3. Okay? Now, that one's a pretty simple one, and most of the time they are. Okay? But let's look at another one. The dimensions of a rectangle are x plus 7 and x plus 2. So these are my dimensions, length times width. And it says here that the area is 66 meters or inches. So we're going to multiply. Now if you need to use the box you can, but I'm going to FOIL it. So we get x squared, 2x, and 7x gives us 9x. And then we get 9. Nope, excuse me, we get 14. We got to multiply. And then we have the 66 on the right side. Now in order to solve this one, because it's quadratic, we've got to move the 66 to this side. So we're going to say negative 66 plus 14. We're going to get negative 52 equals 0. Alright, again we're going to factor, split that first term. The signs are different. So to get 56 when we multiply, but 9 when we subtract. So let's think of something that would go into 56. So, or 52, sorry. I believe 4 will. And 4 times 13 is 52. And if we subtract 4 from 13, we get 9, okay? So we need a positive 9. So our big number, 13, is going to be positive. Our little number is going to be negative. So if we set each of these equal to 0 and solve, this x is going to be negative 13, and this x is going to be a positive 4. So we want to use our positive 4 value. Okay? So let's go up here to our dimensions, and let's see if x is positive 4, then one of our dimensions is 11. Alright, the other dimension is a 6. So 11 times 6 gives you 66. And that was our area. Okay? So it's a matter of setting up the problem correctly. And if you need to draw a picture, I would draw a picture. Okay? Alright, so let's look at some more ways that we can use quadratics to solve equations or solve questions. So here we have a cannonball is fired, and the equation for that pathway is negative 16t squared plus 128t. And t represents time. Okay? So it asks us for the maximum height, and it asks us to find the time it would take the cannonball to reach the ground. So we're going to graph this equation. So we're going to go to Desmos, and we're going to type it in. Now, instead of using t, we are going to use x because the computer only recognizes x as our axis. Okay? Now, I graphed it, but you can see, kind of hard to see my graph. Let me change the color. I'll change it to something else so it shows up a little better. There's orange. Let's try that. Okay? Now, we need, the question was, what is the maximum height? Now, we looked at yesterday, the maximum meant how high did it go? Okay, so that means my graph must be way up here somewhere. You see how I'm moving that down? And I'm just trying to get the top of this graph. Oh, there it is. Okay, so if I click on the graph, it's going to give me that point. All right, now this 256 is the maximum height. Okay? Now it says find the time it takes for the cannonball to reach the ground. Now I need to go back home so I can see where is it touching the ground. Well, it touches the ground at 0, but that's just where it started. It does touch the ground over here at 8. Okay? So it took us 8 seconds to touch the ground. Okay? So this is the y of the vertex, because it's the maximum, and this was one of our x's, our zeros, our x-intercepts. All right? So let's look at the next question. It says when Joey dives off a diving board, the equation of his path is this equation. We got that equation. What is the maximum height that Joey goes? And find the time it will take Joey to reach the water. The water would be the ground as well, so that's going to be your x-intercept. But the height is going to be the maximum. So let's see, how does our equation change? It changes to plus 15 plus 12. So we're going to change that. So here's our graph. All right. So let's look for the top. Oh, there's how high he went. So he went 15.5 feet in the air. So that's going to be the height. And remember, that is the y of the vertex. So we were looking for the maximum height. It is the y of the vertex. Now, how much time did it take him to reach the water? So we want to look and see, where did he come back down? And at what point on x is that? Is that 1 point? We'll say 5 seconds. Okay? So 1.5 seconds in order to reach the ground, or the water in this case. Okay? All right, so let's look at something else. This talks about maximum height and the ground as well. So let's look at this question. It says at the end of the school year, Rachel and Amber go to the roof of a 12-story building and throw their algebra book off the edge. I would not recommend that. The equation of the path that each girl's textbook makes is as follows, or is below. By how many seconds does Rachel's textbook beat Amber to the ground? So we're looking at how much time it took them to reach the ground. Okay? So we're going to put both of these equations in to Desmos, and we're going to compare our equations. Okay? So here we go. We're going to put negative 16 plus 36x plus 160. And then we're going to put that negative 16x to the square plus 50x plus 160. Now, they go really tall, up to 160, and I'm not really interested in that. What I want to see is how long it took each of them to get to the ground. Now, the first equation I put in was Rachel's. Okay, so Rachel was orange here. It took her 4.481 seconds. Okay, 4.481. Now, Amber's was this second equation, the blue one. Okay, and it took hers 5.09. Okay, this is what the question says. By how many seconds does Rachel's textbook beat Amber's to the ground? Now here's their two times. It took Rachel 4.481 seconds, took Amber's 5.09 seconds. So we want to subtract them and find what the difference was. So Rachel's got to the ground in 0.609 seconds faster than Amber's did. Okay? So again, you're looking at x-intercepts, you're looking at the maximum and minimum values, that kind of thing. Okay? Now, I'm going to stop this video and I'm going to do another one that will show you how to do tables. Okay? So we're going to see how to use tables to find our equation and answer the questions. All right?